Today we're going to work with slope fields, they come from a differential equation. So we're just going to look at an example. Let's say that I have the differential equation, and I'm going to abbreviate again, dE, and it is dy dx equals 2x. All right? Well, let's just find the general solution like we did yesterday. Let's do that first. Let's find the general solution to this differential equation. So I integrate both sides. I'm going to integrate the dy dx, and I'm going to integrate 2x dx. And of course, the left side is just going to be y. The right side is going to be x squared over 2, all right, and then I've got this 2 times that plus c. So the 2's cancel, and the general solution to my differential equation is y equals x squared plus c. What does a slope field show? A slope field, and we'll just write this in the form of a note. A slope field attempts to show all the possible solutions to the differential equation. That's what a slope field tries to do. So let's look at how it does that. Let's take this differential equation that we just worked with and see how a slope field does this. They're going to take our solution, which was y equals x squared plus c. And let's think about it. Couldn't c be a whole bunch of things? Let's think of some possibilities over here. Let's think of some possibilities. Couldn't it be y equals just x squared if c was 0? Couldn't it be y equals x squared plus 2? Couldn't it be y equals x squared minus 4? It could be y equals x squared plus 5. It could be y equals x squared minus 5. And couldn't we go on forever? Because we don't know what c is. So what the slope field does is it attempts to graph all of those with dashed lines. So what you see is something like this. Let's take this first one. They're going to put kind of a dashed line. They're more like dashes on the graphing calculator usually. There's that one. And then let's do the next one. Let's do x squared plus 2. Well, that's up 2 units. So it'd be something like this. And then we'll do x squared minus 4, which would be down here. And then we can do x squared plus 5, which would be up here. And then we could do x squared minus 5, which would be down here. Something like this. And so now if you graph a true slope field, it tries to show all the possibilities. So guess what? It has all these filled in here. It has all of them. You know, all of these possibilities are going to be filled in. And that is a slope field for the differential equation that we just started with. All right? And so what you have to do then is you have to have an understanding of what the general solution looks like. All right? So tonight, part of your assignment, you're going to be asked to do something like this. In your book, they're going to say, match the differential equation, and I should have abbreviated that, with the appropriate slope field. Okay? And I'm not going to spend, this is better done actually seeing the slope field, so I'm just going to try to give you a little idea of what you're going to be doing. You have to have an understanding of what the antiderivative is. Let's say that the differential equation is this one, dy dx equals cosine x. And I'm just going to sketch two little possible slope fields down here. All right, I'm going to put, these are going, in your book, they're going to show up as like graphing calculator windows. I'm going to sketch two possible slope fields here, and you tell me which one makes more sense. All right? So here's the first one. And here's the other one. And I'm not going to fill it up all the way. All right, so we will label these choice A, choice B. And so you're asked to match the differential equation with the appropriate slope field. So which possibility, which slope field looks like the appropriate slope field for the differential equation that we're given, A or B? It's B, isn't it? Because this, doesn't this look like sine? Right? What does A look like? Doesn't it look like a cubic? Some kind of cubic, right? Right? So this one looks like a cubic. So if it looks like a cubic, let's think of that for a second. Wouldn't my differential equation, wouldn't it have had to be dy dx equals some kind of quadratic? Right? And that's what you're going to be doing tonight with the slope fields. And we will stop there for today.